A look at why it's not a good idea to mix the facet swap with subdivision. Let's select all of the faces of our polygon, facet, unique points. Now if I insert a subdivide swap, we get each face subdivided, but these edges are not being subdivided at all. They're still perfectly sharp, and that's not usually what you want when you subdivide. In fact, there's another way to achieve sharp or semi-sharp edges with subdivision, and although it's an issue for another tutorial, I'll just demonstrate it here. We turn off our facet, we can see we're getting a smoothed shape. What happens if I wanted semi-sharp or sharp creases? Well, I can either set the crease attribute using a crease swap, or in this case I can overrule the crease swap like so, and increase the crease weight, and we get sharper corners. The facet operation is able to do a few other things other than unique points. It can do the reverse of uniquing points, which is to consolidate points, that is, join them together. It's actually better to use the fuse swap, which has more options to do this, but it's possible to do it here. It can also remove inline points. Let's start again, and I'm going to use the new edge loop tool to create a loop around the middle of our box, and then I'm going to select number 3 for edges. I'm just going to select these two edges, and then I'm going to dissolve them. And what this has done, if we turn on point display, is left us with a spare point here in the middle of this edge that we don't really need. Let me move it a little bit to demonstrate an aspect of this operation. So that's picked up the edge. Move it inwards like that. Now if I lay down a facet swap and press enter, since we can use these two faces, and I remove inline points, nothing happens. What I want to do is get rid of this point. But what this is doing is checking whether the point lies on a line between the two adjacent points. And there's a distance here, distance threshold, which allows it to choose how big a difference from the line there's allowed to be. And in this case it's very small, so it's not recognizing that as being on the line. If, however, I increase this, then as you can see it counts that as being on the line and deletes the point. Another operation that the facet swap can perform is to correct polygons whose normals are in the wrong place. And to simulate that, I'm going to select just the top face of this polygon box, and I'm going to use a reverse swap to reverse the normals just on that top face. And now if we turn on normals, we can see that, let's turn the grid off, we can see that the faces, the normals of the faces, all face outwards apart from this top one where the normal is facing inwards. And this sometimes happens if you're modeling, and it's a good idea to clean up your model by orientating the polygons at the end, and the facet swap allows you to do that. So I'm going to make sure I select all of the faces, because it needs to compare the normals of the face affected with the ones around it, so we need to have all of them selected. Select facet, and then if we have a look at this, we select orient polygons, and we should find, and indeed we do, that the normal is now in the right place. final thing we're going to look at for the facet SOP is the ability to make polygons planar. It's also quite common when you're modeling that your quadrangles will become non-planar, so let's simulate that by selecting a point and then moving it upwards. And as we can see, this top face is now definitely non-planar. Its points are not all lying on the same plane. Let's try and correct that using the facet SOP. Let's first of all try it by selecting all of the primitives, and then if we select make planar, we get an error. The primitive cannot be made planar. The reason for that is because we've tried to get it to calculate this for several faces at once, whereas actually what we need to do is just select the face that's non-planar, and then facet, and then make planar. And as you can see, it moves this point down so that the points are now all planar. In fact, it's not often that useful to do this. You can use a divide SOP to triangulate the non-planar polygons instead.